What if we could terraform Mars and turn it into a second Earth? This idea is often floated by science fiction stories and politicians who like to fantasize about being an interplanetary species. But how likely is it that we'll ever be able to do this in real life? Let's dig into the science of the Martian makeover. Okay, first things first. What exactly does terraform mean? It means transforming an alien world so that it becomes more like the Earth. Usually this involves making the planet solid and not gooey inside, like Jupiter, covered in water and with an atmosphere that's breathable for humans. Why Mars? Well, it's close enough to Earth that traveling there isn't impossible, and it has some things in common with our planet, like a solid surface, a magnetic core, and the right size and mass to keep an atmosphere from blowing away. Plus, Mars was once much warmer and had a thicker atmosphere and lots of liquid water on its surface. So scientists think it might have been habitable in the past and could become so again with a little help from us. Here's the thing though, Mars is really cold now because it's far from the sun and most of its heat has escaped into space. To warm it up again, we'd need a massive greenhouse to trap enough heat to warm the planet up. The good news is that Mars still has plenty of carbon dioxide on its surface, which would be perfect for this job. The bad news is that 95% of that CO2 is frozen solid in the planet's polar ice caps, and the rest is in the atmosphere as a gas. We'd need to somehow melt all of the frozen CO2 and then put the gas back into the atmosphere to make a thick enough blanket to trap enough heat. And here's where things start getting really tricky. To melt the ice, we'd need to raise the average surface temperature of Mars by 6 degrees Celsius. But to do that, we'd need a greenhouse effect. You see, it's kind of a catch-22 situation. We need a greenhouse to melt the ice, but we can't start a greenhouse until we have an insulating atmosphere and a warmer surface to trap heat. So let's just assume that we figured out this problem. Maybe we discover a way to efficiently collect solar energy in orbit around Mars and beam it down onto the poles with a giant laser or something. Well, we've warmed up the planet and melted all the ice. Great. Now what? Well, now we'd need to get that CO2 out of the poles and into the atmosphere. We'd need to sublimate it directly from solid into a gas without melting it into a liquid. And we'd need to do this very carefully so that the warming doesn't blow away the thin Martian atmosphere. And then once it's regasified, it will take hundreds of years to spread from the poles to the equator. But okay, let's say that we figure all that out too. We get ourselves a nice thick CO2 atmosphere. Awesome. There's just one tiny problem. Carbon dioxide isn't very good at absorbing heat. Water vapor is much better at this, but unfortunately, Mars doesn't have much of that. And since we haven't solved the problem of liquid water disappearing into space yet, any water we put on Mars will either freeze or boil away before it can form a nice insulating atmosphere. And there you have it. The Martian makeover is a nearly impossible task. Terraforming Mars is one of those science projects that sounds great in theory. Just put a bunch of CO2 back into the atmosphere and voila, instant global warming. Except in practice, Mars is a very different ballgame. The physics are such that even if we were successful, it would take centuries to transform the planet, and it might not ever really be like Earth. But don't despair. Even if we never make Mars a second Earth, we can still explore it and maybe even set up small colonies there. Thanks for watching.